Hello everybody, making this video here. I hope this is helpful for you. I'm not going to be here today, so there's a couple of things I need to cover with you we did not get to in class today. So the first thing is finding the zeros of a function. And strictly polynomial functions is what we're talking about here. So to begin with, let's look at this function here. We have a function f of x is equal to x cubed plus 3x squared minus x minus 3. I want to point out that the highest exponent in our function is going to tell us how many zeros we're going to get. So we're going to get 3 zeros for this particular function. We're going to find the zeros, and by the way, zeros are the same thing as roots, which graphically means the same thing as basically our x-intercepts. So we are going to set this thing equal to 0, and we are going to solve. And the way I'm going to solve this one is by factoring. So this is going to be a grouping factoring. I'm going to group the first two terms together, and I'm going to group the second two terms together. And in those first two terms, I am going to factor out an x squared. If I were to distribute that back in to get back up to what I had, I'd have to multiply by x plus 3. So you'll see if I did distribute that, I would get right back up to this expression right there. Now I'm going to do the same thing in the second grouping over here, the minus x minus 3. However, this time I'm going to take out a negative 1, because in doing so, I also get an x plus 3 here. So I look at this and I say, okay, I have two terms, a first term and a second term. Both of them are containing an x plus 3. So out of those two terms, I am going to go ahead and we're going to factor out the x plus 3. So when I take the x plus 3 out of both of those terms, what I have is x squared minus 1. So you can see that if we did take x plus 3, this whole thing, and distribute it there and there, I would get right back to the statement that I had. So going a little bit further here, we can take the second guy here, and I recognize that that factors, that's the difference of two perfect squares. So I have x plus 3 times an x minus 1 and an x plus 1. Now the original function, we had said we were interested in figuring out the zeros. So this was really set equal to 0. Well, we have here the product of three things equaling 0, and the only way we can get 0 in multiplying is if one of those three things is 0. So our possibilities here, extend this down a little bit, either this first guy, the x plus 3, is going to equal 0, or this second guy, the x minus 1, is going to equal 0, or this third guy, the x plus 1, is going to equal 0. That's the only way we can multiply these three things and get 0. Solving these, we have an x value of negative 3, positive 1, or negative 1. And these are the three zeros, or sometimes we call those roots of the function. So at this time, I think what we'll do here is we will go ahead and give you an example, and you can pause the video and try this and then resume the video and see how it works. So the function I'm going to give you this time is f of x is equal to x cubed plus 2x squared minus 4x minus 8. This is another factoring by grouping, so you can go ahead and you can pause the video, try it, and then resume the video. So I'm going to group these two guys. Those are my two groupings, and out of the first grouping, I am going to take out an x squared, which is going to leave me an x plus 2. Out of the second one, I'm going to take out a minus 4, and that is also going to leave me an x plus 2. Out of those two terms, I'm going to factor out the x plus 2. Taken out of the first term leaves me only with the x squared. Taken out of the second term leaves me with the minus 4. Now, just like before, in the previous example, this second term here, x squared minus 4, is the difference of two perfect squares. So we're going to take and factor that further. So x plus 2 stays there. Now this becomes, this guy right here is the difference of two squares. I have x minus 2 and I have x plus 2. So having originally set this equal to 0, I have that x plus 2 could equal 0, x minus 2 could equal 0, or x plus 2 could equal 0, giving me the zeros of negative 2, positive 2, and negative 2. Now in this case, we could have said we could have only listed these guys once, and then said that it was a multiplicity of 2, which means that it basically it's the same number counting as two different zeros for the function. So I want to go to the calculator for a minute. I'm going to take this equation, this last one that we did here, this f of x, and I'm going to show you the graph of it just to give you a preview of what we're going to be seeing here with regards to the graph. Now this previous equation had a 0 at negative 2 with a multiplicity of 2, and I want you to see how that appears when we go ahead and we graph this thing. Notice that at negative 2 here, the x value of negative 2, right? Sorry about that. Escape here. Okay, so at the x value of negative 2, we see that it actually touches the x-axis instead of passing through it. That's going to be an important thing here when we look forward at the next topic. So we're going to go back and we're going to try yet one more. And this one's going to factor out a little bit differently. Let's use g of x this time instead of f of x. So we're going to have a negative x to the 4th power plus 4x cubed minus 4x squared. Now this one here, if you want to go ahead and try it, go ahead. You can pause the video at any time and resume it. As always with factoring, we look for a common term that we can pull out of this thing. And in this case, I see that I can pull out a negative x squared. That is a 2 up there. Let me fix that. So when I take out a negative x squared, I have a positive x squared there. I have a negative for x, and I have a positive 4. Going further, we can factor that second parentheses as x minus 2 times x minus 2. And again, if we're finding zeros, we're going to say, well, what are the zeros here? Well, we could have a 0 at any one of the parentheses, the x squared, the x minus 2, or the x minus 2. If either one of those three things is equal to 0, this whole product will equal 0 and give us the result that we're looking for. So it's like writing a bunch of equations here. I have a negative x squared equal to 0, an x minus 2 equals 0, or an x minus 2 equals 0. Now, the first one here is actually like saying negative x times x is equal to 0. So you can see that it's actually two different values, both of those being the x value of 0. This one here, the x value can equal 2, and this one here, the x value can also equal 2. So what we have here is a multiplicity 2, and actually this is a multiplicity 2. So let's go ahead and take a look at the graph of this. Before, in the previous example, I showed you that the multiplicity of 2 meant that the graph did not penetrate the x-axis at that point and only touched it, and then it turned around. So if we look at the graph of this is the equation we just factored. You can see it's the same one. Okay, there it is there. That's the same equation. So I'm going to go ahead and hit enter here and see what the graph is. And sure enough, we can see that the graph touches at x equals 0 and it touches at x equals 2 without actually going through the graph. One thing that we're going to see is that always happens when we have even multiplicities. Whenever you have an even multiplicity, the graph will not pass through. The x-axis. Instead, it's only going to touch it. However, we will see here in a moment when we have an odd multiplicity, that the graph will actually go through the x-axis. So to demonstrate this, I'm going to create an equation that's already factored, and we're going to see that that equation has a bunch of different even and odd multiplicities. We'll graph it and we'll see that we get the behavior that we're saying we're going to get. So the graph I want to look at to demonstrate that is going to be this guy here. We have h of x is equal to x cubed times x minus 4 times x plus 3 squared. So it's already factored to save us the time of having to get it into this form. Now this guy right here is going to be a multiplicity 3, so that's going to be an odd multiplicity. This is only a single one. That's x equals 4, and that's only one root. That's a multiplicity of 1, and 1 is an odd number. However, this last guy over here, x plus 3 squared, that's going to produce two of the same zeros, x equals negative 3 and x equals negative 3. If you wrote it out, we would see that. So we would actually think of this as, that's our even. So if I were to take this function and write it out as x times x minus 4 times x plus 3 times x plus 3, that might give you a little bit more of a view of what I'm talking about with the multiple roots. But when we look at the graph of this, there it is, and I'm going to hit enter. Now before I do, take a guess at what's going to happen at the x value of 0, which is what makes the x cubed equal 0, at the x value of 4, and at the x value of negative 3. Those are the three values that create this function to equal 0. And hopefully you expected to see something like that. We can see that the graph actually bends and turns. It touches at negative 3. It passes through at x equals 0, and it passes through at x equals positive 4. So anyways, I have to end this video now. I have a time limit for how long I'm allowed to make these. So I hope this helps, and I hope you guys use your books along with this to help you get through that homework assignment. I will be back Monday, and I will be ready to answer any questions that you have. But do take the time to watch this. Watch it again if you have to. Look through the book. Look through all the examples in there, and ask me any questions you have in class on Monday. Hope this helps.